Today we are going to dwell one more important topic from business statistic perspective is confidence interval. Whenever we say confidence interval, we tend to think that it applies only to continuous data, that is variable data or anything which you can measure. But however, we can apply to discrete data also as well. Discrete data is also known as attribute data. We can apply. How? Let's go further. How the confidence interval can be calculated? Confidence interval meaning like how the data is being distributed, and we can find out the 5% risk we can have, that is alpha, and then rest other things is that how much points lies in that 95% spectrum. It can be like interval plot, as you can see. It can be in the form of box plot and so on, or commonly used as histogram also as well. So I picked up from this book called Statistics for Manager using Microsoft Excel 7th edition, and there are some examples. So this is an example of the continuous data, and in upcoming slide you will find more details about it. The formula is straightforward: x bar, that is mean, plus or minus m. M is margin of error. That again, if you calculate the margin of error, z times standard deviation divided by square root of n. This is a formula, and then depend upon the z value, like 95% confidence or 99% confidence, at different value that we are going to discuss in upcoming videos in detail. And this is how it gets calculated for proportion. Now the confidence interval has this formula, whereas the confidence interval estimate for the proportion is that p, that is proportion, plus or minus margin of error. The margin of error there it was z into standard deviation divided by square root of n, but here it goes into z whole square root of p, that is proportion, 1 minus p. Let's say p value is 10%. You will write 0.1 into 0.9, 1 minus p, divided by n, how much sample you have. This is a formula we can apply. From there, you can easily calculate for discrete also as well. So the discrete or variable has two distinct formulae. And this is how you can calculate if it is the standard error of means, that particularly we're talking about that in the variable, you will write this way, standard deviation by square root of n, but proportion you'll write this way. And you can apply this one in Excel also as well. In upcoming video, I will talk about it, and this is how we can apply it. For example, let's say this is an example where the length have to be found out. Sorry, newspaper example, and between 13 to 22% defect we have. The average defect is 17.5%. And this is a good example, both in one single slide. And this is the attribute data where you need the proportion and number of success, that is k, and so on. And then for continuous data, you need the mean and standard deviation and so on. From there, we can easily get calculated. And once you get calculated width, we can easily calculate confidence interval lower and upper. So you can also do it in the stat.blue also as well, right? So if you give that proportion, and for example, 10 successes out of 100, that means 0.1 is the p bar, okay? And then you can easily calculate it. The rejection rate is between 4 to 16%. You can easily find it out. And you will see more detail in upcoming videos. Thank you so much. Please do like, share, subscribe, and you have a wonderful day ahead. Follow-up discussion on confidence interval estimation in Excel. As we discussed in the previous video, confidence interval gets applied to both continuous data and attribute data. Continuous data, as we have seen and covered in the past videos also as well, that how we can measure it. For example, length, you can say, okay, this is the range, 10.99 to 11 is going to be the length, right? And this is a scenario for length. Similarly, we can do it for scenario 1, that is newspaper. If the newspaper company want to find out what's the range of defective, right? We can easily predict using this formula. And instead of telling 10%, right, we can also tell the defect is between 4 to 16%. How to do? Let's this is a sample data we have, like sample size is 100 and number of successes is 10. Standard deviation is not applied for attribute data, right? On confidence interval, 95%. That means alpha risk, we are going to leave it 5%. So proportion, so this is, let me do all these calculations. Okay, so proportion is nothing but this 10 divided by 100, 10%, right? And then standard error of p, this is the formula. The formula is square root of P times, you can just give a bracket, 1 minus P, right? That is going to be 90. And then we can say n value is 100. Okay, that means 0.3. So with that, so this z value is, for example, if you say 95%, z value is 1.96, right? And with that, we can directly multiply this z into standard error of P. So with that, we can easily find it out, right? So for example, if we need the lower is going to be the mean, whatever the mean value we have, minus the width value. So that means 4%. And again, mean, the proportion, plus the width is going to be 16%. So we can easily tell. Similarly, you can also apply for continuous data. For continuous data, the formula is slightly different. I'll just focus on formula now. And formula is standard deviation. So this is the standard deviation because it requires a standard deviation, and divided by square root of n. N is 100 in this case. So now with that, we can find out width, and then we can apply on the lower width, mean minus this value, that is width, we can apply, and then mean plus this one. For example, this is the mean plus width. So we can easily calculate the width or confidence interval. First, if you want to change different one like 99, that is also possible. So each z value gets changed based on the confidence interval or alpha value. Thank you so much.